Hello! We have finished beginner phase of the series, having player, character and NPC data as a Python dictionaries and several functions that use this data. But what if we can merge data and functions together into one entity? What if you can pass this entity around and it will always have its state and behavior attached to it? Sounds good? This is what object-oriented programming is about. Let's take a look at our player-character structure right now. This attribute represents player state. Also, character can react to the player keyboard input and move across the map. We have state and we have behavior, which can be merged into a single object. But how do you create an object? You will start with a class. Class is a blueprint which describes all the properties and behaviors object will have. So, let's define player class. As I said, it's just an object description. To create actual object, we have to instantiate it. Python is telling that it's an object of class player, and this is exactly what we wanted. But this character is useless now. First of all, we have to learn how to read and set object attributes. Easy, actually. To access the object property, you use object variable name, dot symbol, and then property name. Setting up the property is the same as assigning value to the variable. Remember, I said that the class is a blueprint. Since it's a blueprint, we should be able to create another instance of this class. As you can see, both characters are objects of class player, but they are different objects with different states. Now let's talk more about properties and object state, especially about the initial state. When we instantiated player object, its initial x and y properties were 0, and after that we set them to the proper value. This means we create object in the invalid state, which is no good. To fix this issue, Python has a special method init, which is called every time object is created. So you can implement this method to be able to set the initial values to the object. Let's do it. What the hell is self, you will ask? Self is a reference to the specific object of the class. For player object, self will point to the player. For player 2 object, self will point to the player 2, and so on. Before we move on, let's change the character dictionary implementation using player class. Okay, so far so good. But what about behaviors? Let's code movement logic as a player class method. And now, instead of manipulating every player parameter directly, you can simply call move methods specifying screen dimensions. Cool, isn't it? Now we can say we attach behavior to the object. Or, to be precise, we encapsulated player data and methods inside the class. Encapsulation is one of the core concepts behind the object-oriented programming. Also a fancy word for what we just did, bundling together data and functions that process this data. But it's just a part of the story. Let's think about movement codes from the game loop context. Does game loop has to know how exactly player moves? Not really. It has to know that player is able to move and call player movement at the proper time. So we can tell that we hide movement implementation details and provide public interface to change object state. We have one more part of code that has to be updated. Again, we are updating the player state directly from the game loop. Allowing external code to manipulate object internal state could be dangerous and hard to debug. Imagine something gone wrong in calculations and you directly set up SpeedX to over 9000 somewhere in the code. Player character is flying to the orbit and you fly into the happy debug hours. So, once again, let's encapsulate this logic into the player class. First, I will add public method to reset player speed values. And to keep things simple for now, I will add 4 methods to set the speed. Nice, now we are allowed to change player state only through these methods. But you can say, wait a minute, despite I have public methods, I still can directly change every property. And yes, you can. In some programming languages, access to the object properties is controlled by the access modifiers. You can mark property as private, and this property will be inaccessible from the external code. So you can access or modify it only through public methods. Python doesn't have real access modifiers, but Python have conventions that by default all the properties are public, and to make property private, you can use double underscore before the name. Let's try to make player character speed properties private. Now, if you will try to access this property directly, you will get an error that player has no attribute speed y, which is not actually true, but good enough to prevent accidental access and changes. Okay, quite a lot of information. I hope that you keep up with me. If you have any questions or suggestions, please leave the comment down below. In the next video, we will talk about class inheritance, and finally we'll give our NPC a face. That's it for now. Like the video, subscribe to the channel, and see you next time. Ciao!